Today we are looking at scientific notation, and this is a method that mathematicians have developed. It's a compact method to write very large and also very small numbers that contain many zeros. So we'll go through some of these examples to show you what happens to the decimal point. So let's just go over the rules given right here. So to convert any number into scientific notation, locate the decimal, and then you're going to move that decimal behind the first non-zero digit. So another way to say this is when you move that decimal point, you want to put it so that it's a number that's greater than 1 but less than 10. Count the number of decimal places that you moved the decimal place, and that's going to become the exponent. If you move the decimal to the left, the exponent will be positive. If you move the decimal to the right, the exponent will be negative. Numbers greater than 1 will have positive or 0 exponents. Numbers that are less than 1 will have negative exponents. All right, so let's look at our first example here. This is a number that is greater than 1. And so we're going to take our decimal point and move it from here. This is where the decimal point is. And we're going to move it all the way so it's here. So it makes the number 9.5. So let's move that. So that's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 decimal places. So that's going to be our exponent. And so our new number is 9.5 times 10 to the power of 10. All right, because we moved it 10 decimal places to the left. And our exponent is a positive exponent because this is a number that is greater than 1. All right, let's take a look at our next example, 865 million. So our decimal point is here. We're going to move our decimal point to the left. 1, 2, 3, 4, 5, 6, 7, 8. 8 decimal places. So our new number, we would write it as 8.65 times 10 to the power of 8. All right, again, it's a positive exponent because our number was a large number greater than 1. So this number here, it's a very small number. It's less than 1. So in this case, our exponent would be a negative exponent. So here is our decimal point, and we're moving to the right. So 1, 2, 3, 4, 5, 6, 7, 8. 8 decimal places to the right. So in scientific notation, this would be 3.5 times 10 to the power of negative 8. All right, so notice now it is a negative exponent because we moved the decimal place to the right, and also because it was a small number. It was a less than 1 number. All right, this is a very large number as well. Ignore that there's a negative there for now. We'll move our decimal place to the left, just like we have been. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So it's 14 decimal places to the left, so it will be a positive exponent. So we write it as negative 1.562 times 10 to the power of 14. All right, and so notice again, it is still a positive exponent because we did move our decimal place to the left. The last number, it is less than 1. We're moving our decimal place to the right. So we are moving it from here 1, 2, 3, 4 decimal places. So we have 8.08 times 10 to the power of negative 4. Okay, so these next examples, we have our number in the scientific notation, so we would just have to write it into standard form. So we have 3.45, and so we're just going to move that decimal place. Okay, so we're just moving that decimal place 6 places, and we know it's a large number because it is a positive exponent. So we're just going to work backwards here. So 1, 2, 3, 4, 5, 6, and then just fill in with the zeros, like so. Okay, so basically this is 3,450,000. All right, and then this one, the exponent is a negative exponent, so we know it's going to be a number that is less than 1. So we're going to move our decimal place to the left. All right, so if we have 7.951, and we are moving the decimal place to the left, so 1, 2, 3, there, and then we would fill in with the zeros like so. And so that would look like 0.000 0.00791. There we go. All right, the next examples, we're just writing the following as powers of 10. So the first one is already done here. 1,000 written as powers of 10 would be 10 to the power of 3. All right, here we have 100,000. That would be just written as 10 to the power of 5. Here we have 1 over 1,000. So that would be written as 10 to the power of -3. And then 1 over 100,000, that would be written as 10 to the power of -5. Okay, so we have these two examples. We're just going to write them in scientific notation. So the first number is a number less than 1. So we know it's going to be a negative exponent. So we just have to move our decimal place to here, our first non-zero digit. It's a number between, it's greater than 1 and less than 10. So 1, 2, 3, 4 decimal places. So this becomes 6.873 times 10 to the power of -4. Here we have a large number, it's greater than 1, and we're moving our decimal place to the left. So 1, 2, 3, 4, 5, 6, 7, 8, right there. So we get 1.568 times 10 to the power of +8.